When people talk about lens compression, they're typically referring to what a telephoto lens will do to the background. A telephoto lens will make the background appear to be closer to your subject. Here's proof that lens compression is not real. I stood in the same position and took 3 pictures at 3 different focal lengths. The 24 is doing what a wide angle lens would do. It's giving me more foreground. It's distorting the images on the side. If you look at the house on the left and right, the 40 is more like your eyes, same as a 50mm lens. This is what the view looked like from my angle with my eyes, not counting peripheral vision. The 62 is not showing me any of the foreground that the 24 is. It's bringing the background closer to me. But is that compression? We said we're going to prove it wrong, and here's where. Let's take a look at the 3 cars on the left-hand side of this image. Let's start with the 60 since that's closest to those cars. And I'm going to zoom in on the 40, and then I'm going to zoom in on the 24. And as you can see, nothing changed. The cars didn't appear to be closer to each other. Now let's take a look at something that could prove that compression is real. You see this a lot over cities where the moon is as big as the skyscrapers. The moon never looks like this when you're in the city. This is an effect that the lens is doing in relation to where the photographer's standing. If compression does exist in a photograph, it exists with 3 variables: the distance of camera to subject, subject to background, and camera to background. If you take 2 pictures from the same location using 2 different focal lengths, the distance between the subjects is not going to change. The only time you're going to see a change between the lenses that we use and the position of the background and foreground is when you move the camera, if you move away or if you move closer. Now, this happens often when you try to keep your subject in frame. Let's take a look at this example.
Mark is going to stand in for us, and I'm going to take a photo of him at different focal lengths, starting at a 16, going all the way up to 300. He's not going to move, I am, so this will prove the theory of distance from camera to subject and camera to background. You ready, Mark? Okay, now this first focal length is going to be a little invasive. It's a 16, so I'll try not to poke your eyes out, okay? This is the 16. Here we are at 24, 28, the 35. Okay, so this is 50. This is a very flattering look. It's a very common portrait focal length. And then we're gonna go up to 70 on this one. So notice how much I moved back. In the beginning, I was right here, and we started to move back as the focal length got longer. I'm gonna try to dial in an 80 on here. That's a very nice focal length. Notice I have to move back now to get him in the same composition. And look how much further I have to step back just from the 100 to the 200. Okay, last but not least, our 300. Mark is standing in shade. It is around noontime. That's not the ideal time to be taking portraits. I want to do one more quick little test. I'm going to start with the 100 and work my way down, but I'm going to stand in the same position. And you'll see how nothing is going to change from the background. If we zoom in, we'll see that the distance between him and the tree behind him isn't going to change. For the 200, this is 100, 75, 50, 35, 28, and 24. As you can see in these examples, when I move, the background get a little bit closer to him. When there's no distance between the camera, the subject, and the background, the depth of field, the focus of field changes. But if you zoom in, you'll see that the distance between him and the tree behind him doesn't change. So that's where we're proving that compression is not real. It's a beautiful magnolia, by the way.
Now, if there's any question about whether this is a real thing or not, let's take a look at one of the most popular examples, the dolly zoom effect, this scene in Jaws. When you're looking at this, you can say, the background's moving away. Yeah, but so is the camera. Here's a behind the scenes photo of that shot. Look at how long the camera's moving towards the subject. And it's doing that because as the zoom is changing, they're trying to keep the subject, Chief Brody, in center frame. And by doing that, by moving the dolly and the zoom in opposite directions, but you're moving the camera and keeping the subject centered. If lens compression was a thing, it would just be a zoom, right? All you'd have to do is zoom in and get the background to move closer, and you wouldn't have to move the camera. I think what's most important here is that as a photographer or videographer, you understand what these different focal lengths do and how they behave. Maybe we should call it lens behavior or focal distortion. The more you become familiar with these lenses, the better you'll be at your craft. Call it what you want. It's an interesting debate. It's fun. If you've made it this far, thank you so much. I really appreciate it. Let's give us a like, hit that subscribe, and we'll see you all in the next video. Thanks, everybody.